Now we have to, in the last two cases we saw a cantilever being. In one case we had a point load at the free end, then in another case we had a uniformly distributed load. Now we have got what? We have to find the deflection of a simply supported beam due to a point load. Okay, the point load is actually exactly in the middle. So first let me draw the deflection of the beam itself first. Let the beam be a little bit long. So there is a support here, there is a support here, and here there is a load exactly in the middle. Okay, let this length be how much? Let this length be L. Then what will happen to this length? This length will become L by 2. Let me call this one as A. I will call this one as B. This point I will call as C. Okay. Now if the beam bends, how does it bend? Because of this, let us just take some other color and then try to draw it out. It will try to come like this because the load is exactly in the middle. It will be something of this type. Okay, like this, right? You can see if I take a point here, this point, the slope at this point is 0. It is horizontal like this. The slope is maximum at B, the slope is maximum at A, right? Deflection is also maximum in the center point, is it not? At A and B, the deflection is 0. Now, what I will do is, I will take a section somewhere over here. I will take a section, I will call this one as X. I will call this one as X. Let this distance be how much? Let this distance be X. Right. Since the load is exactly what do you call W, it is exactly in the middle. What will be the value of RA and RB? If I write a line diagram, you have RA here and you have RB here. RA is how much? W by 2. RB is also W by 2. The load is exactly in the middle, isn't it? Okay, this is W. So if I want at some section, let us say if this distance is X, if I want to find out bending moment at X, what will be the moment at X? If this is X, I can write X is equal to RA multiplied by X. Since the beam is bending upward, it is positive. Okay, what is the value of RA? The value of RA is W by 2. W by 2 multiplied by X. Okay, and also we know the differential equation for the beam deflection, that is EI into T square Y by dx square is equal to M, is it not? Let us equate these two equations. I can write EI into D square Y by dx square is equal to W by 2 into X. Now we will first integrate. Now what shall we do? Let us integrate. If we integrate, what is the value I am going to get? Let me write the equation also. Integral of d square y by dx square into dx. W by 2 is constant into x dx. So it will be how much? EI into dy by dx is equal to W by 2 into x dx means what? X square by 2, is it not? Into x square by 2 into 2, this will become 4 plus C1, let us say. Okay, fine. So now if I want to find out C1, what I should do? I should apply the boundary conditions. Now here, if I go up and see, the slope is 0 where? The slope is 0 at this point, is it not? At point C. It is at a distance of what? When x comes over here, the distance of x is L by 2, isn't it? I can simply say at x is equal to L by 2, dy by dx is equal to 0. So now let us write 0 is equal to W by 4. Instead of x, I am doing what? L by 2. This is whole square, is it not? Plus C1. So this becomes how much? WL square by 4 4 is 16, isn't it? 16 plus C1. Therefore, C1 is equal to minus WL square by 16. This will become what? This will become the value of what? The value of C1, right? So now if I substitute this value of C1 into the equation above, what I will have? I will have EI into dy by dx is equal to Wx square by 4. Instead of C1, I will have minus WL square by 16. This is what? This is the equation of slope. Okay, this is the equation of slope. Now again let us integrate it. Integrate again. If you integrate again, what I will have? I will have EI into y is equal to W into x cube by 3. 3 fours are 12 minus WL square by 16 into x plus C2. Okay. Now again let us apply the boundary conditions. So what I will do now, I will have a line in between and let me separate it out. I will have a line in between. There is some space here, is it not? Yeah. I will have a line here. Okay. Let me write on this side now. So what I will write now, I will just write when x is equal to 0, your y becomes 0, is it not? See, you go up, you see here at this point y is 0, at b y is 0, correct? So now let us just write into this equation what happens into this equation. This first term will also go, second term will also go. C2 is equal to what? C2 will be is equal to 0, is it not? So I can say 0 is equal to 0 plus 0, where is that? Sorry, 0, then you have plus C2, is it not? So I can write, directly I will write C2 becomes is equal to what? C2 becomes is equal to 0. C2 becomes is equal to 0. Therefore, EI into Y is equal to Wx cube by 12. Let's go back and check the formula again. See here, Wx cube by 12. Wx cube by 12 minus WL square by 16 x plus C2 is anyway 0. Okay. This is what? This is your equation of what? This is your equation for y. So now you can easily write the value of dy by dx is maximum when x is equal to 0. Correct, Shabab? Now go to dy by dx equation. Where is dy by dx equation? It is here. Right. So I can write EI into dy by dx is equal to what? Is equal to minus W L square by 16. Correct. This is the maximum value. Y is maximum where? Y is maximum when x is equal to L by 2. Correct. You just go and put it in y equation. Understand? So I can write it as what? So 1 minute. Let me just take this EI on the other side. If I remove EI, if I put it on the other side, it becomes 16 EI, I can say. Y will be maximum when x is equal to L by 2. So what can I write? I can write Y max is equal to minus, I can write 1 divided by EI into W by W instead of L I will have L cube by 2 into 2 into 2, that is 8. 8 12s are 96. 96, you have this one, and minus W into L square. L square is L by 2, is it not? L square by 4. 4 16s are how much? 64. If you subtract and all those things, then you will have Y max is equal to WL cube by 48 EI. Okay, see here. But here I made a mistake. Just let me correct. Sorry. Let me correct it a little bit. This is not 64. This is how much? This is 32. Okay. WL cube by 48 EI with a minus sign, you have it over here. Okay. This is what? This is your Y max. That's it. This is the equation. Okay. So you have to remember these equations if you want to solve the problems. Okay, Shubham?